Social symbiosis, like any other type of symbiosis, requires at least two individuals of different species that cohabitate and interact with each other in some way. However, social symbiotic relationships are thought to have more than two individuals interacting together. Social symbiotic relationships include multiple organisms interacting at the same time, instead of it being a one-on-one interaction. For example, one dog and one tick, which would be a parasitic relationship. The organisms involved in a social symbiotic relationship could include multiple individuals of the two symbiotic species, for example, one dog and many ticks on the dog, or social symbiosis could include a variety of species all interacting together. An example of this would be a coral reef cleaning station, which is an example of a mutualistic social symbiotic relationship that includes an abundant amount of species working together. And like other symbiotic relationships, social symbiotic relationships can be mutualistic, parasitic, or commensalistic. Social parasites take advantage of interactions among members of highly social animals, such as bees, termites, and ants. Social parasites take advantage of these host species because of how they interact and work together in such a structured way. For example, certain bees in a colony have certain jobs, such as housekeeping bees, bees that guard the hive, bees that collect nectar, bees that take care of the queen bee, and bees that take care of the larvae in the colony. An example of a social parasitic species would be a bee species called Bombus bohemicus, which invades other beehives and exploits the host bee colony structure. The parasitic bee lays its larvae, and the host worker bees that take care of their own colony's larvae end up taking care of the parasitic bee's larvae as well. Commensalism is a relationship between two species where one species benefits and the other species is unaffected. One example of social commensalism are cattle egrets and cattle. Cattle egrets originate from Africa, and unlike most native egrets in North America that feed in or along water edges, cattle egrets feed in close association with cattle. They follow and forage in pastures alongside the cattle, where they eat the insects that are stirred up by the hooves of the cattle. This relationship can be considered commensalism because the cow does not benefit from the egret eating insects in its tracks. However, in some instances, some cattle egrets have been seen to sit on cows and eat irritating insects off the cow's body, such as ticks. In this instance, this relationship could be considered mutualistic because the cow does benefit by having parasites removed from its body. Mutualism is where two species interact together in a way that benefits both species. One example of social mutualism are clownfish and sea anemones. 10 out of over 1,000 anemone species coexist with 26 clownfish species. Those 10 sea anemone species and the 26 clownfish species are obligate symbionts, meaning they need each other and greatly depend on each other for survival. Sea anemones provide clownfish with a safe, protective home, while clownfish species provide the sea anemone by cleaning the sea anemone, providing nutrients from wastes, and scaring away predatory fish such as butterfly fish away from the sea anemone. However, sea anemones are venomous species of coral, so how does this relationship work without killing the fish? The reason sea anemones are dangerous to other organisms is that they have hundreds of tentacles with nematocysts on them that are harpoon-like stingers that release venom. They are used to capture prey and protect against organisms around them. Clownfish species protect themselves from the anemone's venom through mucus layers. The mucus layer a clownfish is born with is already thicker than the average mucus layer of other fish. Over time, the mucus layer grows and the sea anemone can add mucus from itself to strengthen the mucus barrier of the clownfish. Overall and over time, the mucus layer of the clownfish can be 3 to 4 times thicker than other fish. Some clownfish mucus layers are so thick that their first contact with sea anemones are harmless, while others have to acclimate to sea anemones by rubbing up against their tentacles. And at first the clownfish are stung, but over time they appear unharmed by the sea anemone's venom. Most clownfish acquire antigens, presumably from the mucus provided by the sea anemone they inhabit. This was referred to as chemical camouflage, and some scientists have found that the acquisition of these antigens, the anemone is no longer able to distinguish between itself and the clownfish. The result is that the anemone no longer reacts to the fish by stinging it. Both zebras and ostriches tend to travel in herds within their species, but they also travel together for safety. Zebras have a great sense of smell and hearing, so this allows them to smell or hear a predator in the area. However, with their poor eyesight, they can have trouble pinpointing the location of a predator. This is why they travel with ostriches. Ostriches have great vision, which allows them to pinpoint the location of a predator, but they have poor senses of smell and hearing. So with their combined sense, zebras and ostriches are more prepared to stay clear of predators or sense that they are in the area. And often gazelles will join in the herd for added measures of senses and alarms. Coral reef cleaning stations are another example of social mutualism. Reef cleaning stations are places where animals go to have dead skin, bacteria, mucus, and parasites removed from their flesh, gills, and mouths by other species. Client species settle into a cleaning station and signal organisms that they want to be cleaned by either fluttering their gills or opening their mouth. This can be considered a social symbiotic relationship because usually when an organism wants to get cleaned, a variety of smaller species clean the organism. Reef cleaning stations benefit client organisms by helping them avoid infections, especially around wounds, while reef cleaning stations benefit the organisms that clean by giving them an easy meal. Scientists have found that in some places, animals will aggregate in huge numbers of cleaning stations, and there appears to be some kind of understanding and communication about taking turns and a hiatus on predator-prey behavior. Client species that participate in cleaning stations are manta rays, sea turtles, moray eels, pufferfish, and groupers. And species that help clean the client organisms are surgeonfish, gobies, shrimp, crabs, tangs, bleenies, and wrasse. And it is interesting, scientists have noticed that the species that clean the other organisms often have blue or yellow coloration and stripes that scientists assume advertise their services.